Well, welcome everybody. This is our very first lesson of notes that we're doing today. And like always, notes will be on the board when you first walk in the room, unless, of course, this year, that first time we walk in the room happens to be online. So notes are supposed to be copied exactly the way you see them on the board. It's generally short bits of information that tell us what we're doing. You'll have brand new vocabulary words over here that we need to learn because in math, it's all about being able to use the proper words to describe what we're actually trying to do with the numbers and the letters that we use in algebra. Now, as we get started, we'll notice that all of these notes here, and I'll show you, they're going to be titled like 1-1. This refers to our Pearson textbook. So this is Chapter 1, Section 2. It's like 1.2, Order of Operations and Evaluating Expressions. So some of this you're going to find within the first section of algebra is probably super easy for you. By this time, I hope that we all know PEMDAS, parentheses. We have exponents. Of course, that's the little subscript, superscript that's up here. The parentheses are here. They're usually telling us, hey, look at something. You have to do this part first. Exponents are when you're raising something to a power or the number of times you multiply this base in a row. Multiplication, like 2 times 3, 6. Division, 6 divided by 2, 3. Addition, subtraction, PEMDAS, the order in which we do things. So we're going to have problems where there's going to be multiple steps to it. Well, where do we start? We have to start somewhere to get to the end. We use this chart here, PEMDAS, parentheses, then exponents, then multiplication, then division, addition, and subtraction. Okay, so what's really key here is you're going to see we use the PEMDAS, like I just said. It's used to evaluate expressions. Then as we start to evaluate them, then we have to combine like terms. Like terms have the same variable. And for an example of this, we use variables all the time in algebra. So when we have an unknown or we don't know what exactly we're dealing with, we use letters or symbols to represent that. So we can always combine the ones that are exactly the same together. So here's a good word problem here. It says if you have 3 apples and 2 pears, and Joe takes 1 apple, how much fruit do you have left? So we think about this as far as variables. So our variables in this case are apples, pears, and then what? Joe takes another apple. So if you have 3 apples and 2 pears, and Joe takes one from you, how much fruit do you have left? So we could say 3A for apple minus 1 apple, because Joe took that away from us. He must have been hungry. And then we still have 2 pears, and we'll use P for pears. Well, now we're going to do this combining like terms. Our like terms are the A's. If you can see, we have an A here, and we have an A here. So if we have 3 A's, and somebody takes 1 A away from us, 3 minus 1, the coefficients of the variable, tells us how many of that variable we have. So 3 minus 1 is 2. So there are 2 A's left. Plus, well, we only have 1 set of P's, 2 P's. And that would be your final answer. That's your first like crazy algebra problem. Who knew you'd ever be doing math with letters and symbols in it? So if you have 3 apples, 2 pears, and Joe takes one of your apples, how much fruit do you have left? Well, we have 2 apples and then 2 pears left. So recapping some of this vocabulary terms that we have, it's really important. I cannot tell you, I will stress with you in this in class over and over again. Vocabulary is key to understanding what we do. We don't like to call things thingies, the stuff under the bar. That would be variables, or maybe like your denominator. That's the stuff underneath the division bar, or the numerator is above it. Key vocabulary concepts here. A term. So in algebra, a term is any grouping that is separated by addition or subtraction in an expression. Like our previous example that we had here, 3a minus 1a plus 2a. This would have three terms. There's three individual pieces that are being separated by addition or subtraction. The end answer was only two terms because there were two pieces that were being separated by addition or subtraction. Like terms are always the ones that have the exact same variable. They look exactly alike. The numbers in front or the coefficients can be different, but we can combine the ones. So if you have, like in that first example again, 2a minus 1a, so 2 minus 1 is 1. 2 minus 1 is 1. So you're able to combine terms. 2a minus 1a. Because the variables are exactly the same, you're allowed to combine them together. So 2 minus 1 is just a single a, 1a. Notice I didn't write the 1 here. It's called invisible math. We don't generally write 1s in front of things. Variable. Again, variable is that unknown. That's the whole purpose of algebra, guys. We are solving for the very first time for an unknown piece. Well, we have to use something to represent that piece. So we'll use alphabetical letters. Sometimes you'll see Greek symbols and things like that. Not very often in our class, but you may see it here and there. The most common one you might see for a variable that is not a normal letter is like the variable pi. Of course, we know that's 2.14 and it goes on forever, but sometimes you'll just see the symbol and then we don't mess with it because it's just representing something. Okay. Expressions. Expressions are word problems that we take the word problem, those dreaded things that nobody likes. We take a word problem and we translate it into this mathematical terms here, like we did with the apples from before, when we had, what, 3 apples, 2 pears, and somebody takes 1 apple away. So 3 apples minus 1 apple plus 2 pears. We combine like terms and we solved. Going on, we're going to have, okay, PEMDAS. PEMDAS tells us how we need to approach an expression. So what do we do first? When we plug everything in, what do we do next? Like, and how do we start? Where do we start? PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. This tells us how to approach an expression and where do we start to do the math first. Then we simplify everything. So simplifying it, we do that math, and when we get down to the end, we combine any like terms if we have them. So if the problem happens to have a variable or something in it, we combine all of our nice whole numbers or the constants together, and we combine our variables that look alike, and if everything's different, we just rewrite it and leave it be. Of course, we'll see examples of that. So something that's key in algebra, and this is a note, that's why it's starred. Make sure in your notes, whenever I have things that are starred, highlight them. It's very important. If we are given the value of a variable, we can then use the substitution property to be able to replace that value and evaluate an expression. For example, if we went back in this problem here, say we don't know what A is, but if I told you A equals 1, well then you legally are allowed to say in math, because everything is about rules. I'm very rule oriented because we have to learn how to use and apply rules in our class. If I tell you that A equals 1 in this problem, then it's said that if A equals 1, I am allowed to take this A out and stick a 1 in its place. So I could definitely do A, we wrap a set of parentheses around it, plug in a 1, minus 1 times get rid of that A and plug in a 1. So 2 times 1 is 2, because PEMDAS says we do multiplication before we do subtraction, and 1 times 1 is 1, and then 2 minus 1 is 1. So that's like what the law of substitution says. The law of substitution says if we give you the value of a variable, you are allowed to plug that value in and then evaluate. So very, very, very key concept that we start with. If we give you the value of a variable, you are allowed to substitute it into that problem everywhere that exact little variable sits. And this starts some of our examples. Okay, what we're going to do first here is you're going to see here is an expression. We have 3 squared plus 2 plus 1 in parentheses, and then that squared, or they sometimes say raised to the 2nd power. Either way. We say, well, where do we start off with first? Where do we even go? Well, like I said from the very first thing, PEMDAS, write it on your paper. Parentheses, exponents, multiplication, division, addition, subtraction. So now we have to say, okay, so you start off with the first one. Do we have any parentheses? Yes. Parentheses always scream out at you, hey, look at me. And what is it telling you to look at? It says look inside of it. So here's what's inside. Because parentheses are first, what do we do first? We add the 2 plus 1, which is 3. And then that's squared. And then this is still squared. Okay, so now we're stuck here with 2 different operations. This term here is saying we raise it to a power or an exponent. Then there's an addition, and then here's another exponent. Well, PEMDAS says, because we've already gone through this, exponents are next. So 3 squared. 3 times 3 is 9. And we have the same thing here. 3 squared is 9. All right, so exponents are done. Is there any more multiplication? No. Any division? No. Is there any addition? Yes. 9 plus 9 is 18, and that would be our final answer. You've just evaluated your very first expression. Now here's 2 more. Only this time, notice what's different with our expressions. This time, in these 2 expressions here, we have variables stuck in them. Now these variables, it's quite interesting how these variables work, because as you sit here and you look at these, at the very top of these sets of examples, it gives you if x equals 3 and w equals 2. That means we're allowed to do our laws of substitution. So we said that x equals 3, so in this first one, we can come in here and we replace this x with a 3. And then we can replace this w with a 2. Notice how I wrap what I'm replacing in a set of parentheses. Very important to do this. Now, PEMDAS, if you've wrote your PEMDAS at the top of your paper, great. Parentheses are first. Well, we have parentheses in parentheses. So go to what's inside the most. Well, it's just a 3 and it's just a 2, but it's telling us to add these together first. And it's inside of a set of parentheses, so we can do that. So 5. Great. 5 raised to the 3rd power. Well, this means we take 5 and we multiply it 3 times in a row.
Staff, our 2 o'clock meeting will be this afternoon in the cafeteria. Please start making your way down there so that we can start on time and finish sooner than later. Again, our after
All right, so we have 5 times 5 is 25. And 25 times 5, well, that's 125. And that's our final answer there. You guys go ahead and give this next one a try. Let's see if I can confuse you. I've added a couple more terms in here, but it shouldn't be too bad. Take your X's, take your W's, substitute it in, and then we'll get back to it. I'll give you a minute to try to work on this.